Hi guys, GoodGolf here with a new video in the Mirror series. This time I will look into 3 questions asked in the video comments. Using Invector Pro version, saving game data, concurrent user limits and how to deal with it. Let's start with the simplest question to answer. In the early videos I used the free version of the Invector third-person controller. Later on, I switched to the Pro version and the question was asked if I could show how to use that. The answer is that it's mostly the same as using the free version. However, there are a few differences. The Pro version has a lot more components, some of which are in objects underneath the main character controller object. So, you will need to create a much longer list of references to these objects and their components. Similar to using the free version, disable the whole lot of components in the awake function and only enable them for the locally owned player in the onStartLocalPlayer method. This is what it looks like. In the awake function you can see that some of the components are attached to the top level object, while others, like the camera, are attached to a child object. Question number 2 from the Brian Sen. How to save your game data in a multiplayer game? This does depend on how your game is hosted, although the basics of saving a game usually are the same. Let's first look into the basic options of hosting your game. If you run the game in a peer-to-peer setup, then one of the players is hosting the game on his or her PC. Next to hosting the game, that player also runs a client. Alternatively, you can host the game on a server, for example in the Google Cloud or in Azure. Some games support both options. I know of 2 games built with Unity supporting this, Valheim and V Rising. Okay, let's start with option 1, peer-to-peer. We have one player hosting the game on his or her PC. The host has a copy of all player objects. Actually, it has the original objects, since the network instantiate sort of owns the objects on the host. Since all objects are on the host, you can simply collect them and store the data wherever you want. Locally, in the cloud, and if you're using Steam, store locally, then sync it automatically to the Steam cloud. This only requires saving it to the right local folder. I do recommend encrypting the data to prevent players tampering with it. For option 2, you will need to create a server build, which runs in a headless mode. Steam does support that. I will look at it in a later installment of the video series. If you want to see how that turns out, then check the link for V Rising. If you run the host on a server, you can simply store the data in a local folder, since only the server admin will have access to it. Do encrypt the data. And how does the storing of the data work? On a certain trigger, you collect all game data. Make sure you put it in a class which is serializable. You can then convert the instance of this class into a string using JSON utility to JSON. Now you can store the string wherever you want. Locally, by writing the string to a file, in the Steam Cloud Sync folder, or use my favorite. Use an Azure function to store it in a cheap Azure storage account. This has the benefit that other players can access the data if you want that. When you restart the game, you can load the data once the players have connected. Based on their authentication, you can assign player data to the right client. In Steam, you can simply use the Steam ID as a unique authentication ID. How about the encryption? I also like to do that using an Azure function. You simply submit the JSON string to an Azure function using the web request, and the Azure function returns an encrypted string. Why use an Azure function for this? Well, it has the benefit that the encryption key is not stored in your code. This adds another hurdle to tampering with the save game data. But to be honest, I also do this because it's fun to create these Azure functions and learn how to integrate them into Unity, because it does require some learning to do web requests and async operations. If you want to look into Azure Functions, I highly recommend watching Tim Corey's channel. He has a step-by-step tutorial which I will put in the video description. You only need an Azure account, the free Visual Studio Community Edition, and some C# skills to make it work. Now for the last question from Violent Gamer. Let's look into CCUs. The number of concurrent users in a single host when using Mirror is limited to about 50 to 60. So how can we increase that number? Right off the bat I see 3 options. I will briefly review each of these 3 options. Switch to fish networking, switch to dots networking, or rethink your server host instance model. First of all, you can simply switch to fish networking. It's similar to Mirror, boasts a 10-fold increase of CCUs, and the migration is supposed to be pretty straightforward. I'm going to try that soon and will report back to you. The original reason why I want to move to fish is because it's authoritative by design, and it's also free. Dots networking for sure is not free, but it is designed for MMOs and promises thousands of CCUs. Beware, it only supports a very specific single Unity version. Also, it builds on the ECS and jobs system, which may take some time to learn. I don't expect any migration approach from Mirror. You probably need to start from scratch. And now to rethinking the instance model. I've read an article about this years ago and I'm explaining from memory. I'm also mixing in some concepts of other games and Guild Wars specifically. The basic idea is to have multiple mirror hosts on a single server. Each host is responsible for a map instance, for example a city, a dungeon or an outdoor map. When there are too many CCUs/clients connecting to a single map, it overflows into a newly started host with the same map. This overflow instance can be located on another server and clients will need to be redirected to this overflow instance. Players can only see other players on the same host. They may be able to see the global and map chat from other hosts. When you keep adding more clients, at some stage the server runs out of computing power and performance drops. So, when a watermark level on the server is reached, you need to provision another server in the background. You can do that by script in any of the cloud providers like Azure, Google and AWS. You will need to kick off that script whenever a certain number of clients and hosts is reached on a server. That way you are ready to add additional overflow instances on a server which is ready to go. When the number of clients and overflow instances is decreasing, you can of course shut down the server. This way you can scale the number of servers needed based on the population in the game. For this to work, the hosts need to be flexible in the map they get assigned to host, the port number they host the map on. This way, multiple hosts can run on a single server. Be able to redirect the clients from one host to another. You probably do this when the player exits a map through a gate, a bridge or a portal. You will need a map master table which tracks which maps are hosted on what server, on what port and with what population level. Through that table the hosts can check where to send clients when they leave their map. For global chat, matchmaking and authentication you can use Steam. For the marketplace you may want to create a separate solution. I'm thinking a cloud-hosted NoSQL table which the players can access to list and buy items. These are the fundamentals, and depending on your game type you may want to make some changes. I will try and build a proof of concept to share. Mind you, this will take some time, so you may see other videos appear in the channel first. Okay, that's it for now. Thanks for asking these questions and keep them coming. I'm off preparing the next video.